Good morning, all of you. In this session, I am going to explain about problems on structural joints or loosened joints. This is the example problem. In this session, I will explain about this problem. Before going to the problems, first of all, you have to know the fundamentals, how to design a structural joint. The following steps are used for design a loosened joints. Let width of a plate is B. Here B is the width of a plate and T is the thickness of a plate. Okay, thickness of a plate. Small d is the diameter of the rivet hole. Rivet hole. Okay, small d is the diameter of a rivet hole. And in designing a loosened joint, the following procedure is adopted. In first step, you have to determine the suitable diameter of a rivet hole. Okay, from this equation, you have to determine a diameter of a rivet hole. So small d equal to 6 root t. T is the thickness of a plate. Okay. After getting the diameter of a rivet, you have to select a standard size from this table. Okay, from this standard sizes table, you have to select a proper rivet hole size and rivet diameter. Okay. In second step, you have to determine number of rivets required for structural joint. Okay, small n is the number of rivets required. For determining the number of rivets, first you have to determine tearing strength, shearing strength, and crushing strength. Okay, here PT is the tearing strength. PT is the tearing strength. Already we know that this is the formula for tearing strength. B minus D into T into sigma T. B is the width of the plate. D is the diameter of the rivet hole. T is the thickness of the plate. Sigma T is the tensile stress induced in the tensile stress induced in the plate material. Okay, plate material. Okay. So after that, you have to determine a shearing strength. Here, this is a double strap butt joint. Okay, for double strap butt joint, you have to consider double shear. Okay, for lap joints, you have to consider single shear. Okay, and also for single strap butt joints, also single shear. But for double strap butt joints, you have to consider double shear. Okay, so this is the formula for double shear. Okay, PS is the shearing strength or shearing resistance of rivet for one rivet. Okay, 1.75 into pi by 4 d square into tau. Okay, now PC is the crushing strength or crushing resistance of the rivet. Okay, D into T into sigma C. Here sigma C is the crushing stress in the rivet material. Tau is the shear stress induced in the rivet material. Okay. From tearing strength, shearing strength, crushing strength. Okay. You have to determine the value of N. Okay, N equal to tearing strength divided by least value of shearing or crushing. Least value of PS and PC. Okay, this is the formula for number of rivets required. In third step, after getting the number of rivets, you have to arrange a number of rows. Okay, you have to choose or select a required number of rows. Okay, in each row, number of rows and a number of rivets in each row. Okay, this is the example. Okay, here there are 7 rivets in 3 rows. Okay, this one is the first row, this one is the second row, this one is third row. You have to arrange in diamond shape. Okay, In fourth step, you have to determine a suitable thickness of a butt strap. Okay, for a single strap butt joints, you have to consider T1 equal to 1.25 T. For double strap butt joints, you have to consider 0.75 T. Okay, for a single cover plates, okay, single cover plates, you have to consider 1.25 T. For double cover plates, you have to consider 0.75 T. Okay. In fifth step, you have to determine the efficiency of the joint. This is the formula for efficiency of the joint. Efficiency equal to least value of tearing strength for first row, tearing strength for second row, PT2. PT3 is the tearing strength in third row. Okay. PS is the shearing strength. PC is the crushing strength. Okay. So least value of PT1, PT2, PT3, PT4, and like this, PS or PC divided by strength of the unriveted plate, P dash. Yeah, this one is P dash. This one also P dash. Okay. So here you can observe in first row. In first row, there are only one rivet. There is only one rivet in first row. So for a tearing strength for row, first row, PT1 equal to B minus D into T into sigma T1. Okay, this is the tearing strength for first row. Okay, in similar way, tearing strength for second row. Okay, in second row, there are two rivets. Okay, there are two rivets in second row. Here, this one, this is the second row. So in this second row, there are two rivets. So for two rivets, you have to consider number 2 times the diameter of the rivet for two rivets. So B minus 2D into T. Okay, for two rivets, you have to consider 2 times diameter. Okay, plus shearing strength of the rivets before second row. Okay, in front of second row, there is only one rivet. So you have to consider shearing strength of this rivet also. Okay. In third row, there are three rivets. In third row, there are three rivets. So you have to consider tearing strength for three rivets. So you have to consider 3 times the diameter of the rivet for third row, B minus 3D into T into sigma T plus shearing strength. Shearing strength for remaining two rows. Okay, here in front of third row, there are three rivets. Okay, so you have to consider three rivets shearing strength. Now P dash is the strength of unriveted plate. Okay, so this one is the efficiency of the joint. Efficiency of the joint, zeta equal to least value of PT1, PT2, PT3, PS or PC divided by P dash. P dash is the value of B into T into sigma T. Okay. After that, you have to determine row pitch. Row pitch. Okay. That means the distance between two successive rows is called row pitch. Okay. In sixth step, you have to determine proper row pitch. In seventh step, you have to determine margin. Margin means the distance between the center of the rivet to the nearest edge. Okay, the distance between the center of the rivet and the nearest edge is called margin. So the value of margin M equal 1.5D. This one is fixed value. In last step, you have to determine number of row distance between rows. That is row pitch. So this is the example problem. This is the application of a structural joint. A tie bar in a bridge consists of a flat 350 mm wide and 20 mm thick. It is connected to a gusset plate of the same thickness by a double cover butt joint. Design an economical joint if the permissible stresses are sigma T equal 90 megapascal, tau equal 60 megapascal, and sigma C equal 150 megapascal. Okay, this is the given question. From this, from these given values, you have to design a structural joint. First of all, you have to identify given values. Here, the width of the plate is 350 mm. Okay, this one is a small b. Width of the plate is b equal to 350 mm, and this one is the thickness of the plate, that is small t. T is the thickness of the plate. Okay. Now, this one is a tensile stress. Tensile stress induced in the plate material. Okay, tensile stress induced in the material, sigma T. This one is the shearing stress. Shearing stress induced in the rivet material. This one is the crushing stress induced in the rivet and plate material. Okay. So the given values are width b equal to 350 mm and thickness equal to 20 mm. Tensile stress equal to 90 megapascal. 1 megapascal equal 1 Newton per mm square. Shear stress tau equal to 60 megapascal. Crushing stress sigma C equal to 150 megapascal. Okay. So these are the given values. In first step, you have to determine a suitable diameter of a rivet. So this is the formula for diameter of a rivet, d equal to 6 root t. So here small t is the thickness of the plate, that is 20 mm. So diameter of the rivet d equal to 26.8 mm is the required diameter of a rivet hole. But you have to select a standard size from this table. From this table, you have to select a standard rivet hole diameter. So here our answer is 26.8 mm is the answer for rivet hole diameter. So from this table, you have to select a nearest value, nearest to the 26.8 mm. Here, from this table, you can observe 29 mm is the nearest value. Okay, nearest to 27 mm. So this one is the diameter of the rivet hole, 29 mm, and the corresponding diameter of a rivet equal to 27 mm. So from this table, I selected these two values. Okay, diameter of a rivet hole equal 29 mm and diameter of a rivet equal 27 mm. Okay. Now, in second step, you have to determine a total number of rivets required. That is small n. In second step, you have to determine number of rivets required for joint. Okay. For determining the number of rivets, first of all, you have to determine tearing strength. Tearing strength. Okay. This is the value of this is the formula for tearing strength, b minus d into t into sigma t. Tearing strength for one rivet. Okay, 5,77,800 is the value of tearing strength. Okay, for the then after you have to determine shearing strength for one rivet. Here this one is a double strap butt joint, so you have to consider double shear. Okay, double shear for a single rivet. PS is the shearing strength. Shearing strength for one rivet. 1.75 into power 4 d square into tau equal to 69,360 is the shearing strength. After that, you have to calculate crushing strength, PC. This is the formula for crushing strength, d into t into sigma c. D equal to 29 mm, t equal to 20 mm, sigma c equal to 150 mm. Okay, the crushing strength is 87,000 newtons is the crushing strength. Okay. So from these three values, you have to determine number of rivets required. Already we know the formula for number of rivets required. N equal to tearing strength divided by least value of PS PC. Here the least value of PS PC is 69,360. So that is least value is PS, and PT value is 5,77,000. So from this equation, the number of rivets required n equal to 9, approximately 8.33. So you have to consider rounded value, that is a 9. Number of rivets required equal to 9. Okay, n equal 9 rivets required. After getting the number of rivets, you have to arrange. Okay. In the third step, you have to arrange the number of rivets in diamond shape. Okay. So here you can observe this is a first row, this is a second row, this is a third row, this is a fourth row. Okay, in first row there is only one rivet. In second row there are two rivets. In third row there are three rivets. In fourth row there are three rivets. Okay, so totally 3 plus 3 plus 2 plus 1, total 9 rivets. Okay, so this is the arrangement of the joint. After that, you have to determine the thickness of the butt straps. Butt straps, that means the thickness of cover plates. For double strap butt joint, for double straps, you have to consider T1 equal to 0.75 T. For single straps, you have to consider 1.25 T. Okay. Here we are using double strap, so you have to consider T1 equal to 0.75 into T. Okay. Already we know the value of thickness of a plate, T equal to 20 mm. So T1 is the thickness of the strap. Here, this one. This is a top cover plate. This is a bottom cover plate. So 15 mm is the thickness of a butt strap. Okay. After getting the values, you have to determine the efficiency of joint. Okay. For determining the efficiency of the joint, first of all, you have to determine tearing strength in first row, tearing strength in second row, tearing strength in third row, tearing strength in fourth row. Okay. First of all, let's find the resistance along the section 1-1. Okay, along the first row. So at section 1-1 or in first row, there is only one rivet hole. Okay, so the tearing strength for single rivet PT1 equal to B minus D into T into sigma D. PT1 means tearing strength in first row. Okay, suffix T1 means tearing strength in first row. Okay, equal to B minus D into T into sigma D. Here there is only one rivet, so you have to consider single diameter. Okay, so B minus D into T into sigma D. So the value is 5,77,800 newtons. Okay. In second row, at section 2-2, there are two rivet holes. There are two rivet holes. So you have to consider two diameter. Okay. So PT2 is the tearing strength for second row. At section 2-2, there are two rivets, so you have to consider 2 times the diameter of the rivet. Okay, 2D for two rivets. Okay, B minus 2D into T into sigma T plus shearing strength of one rivet. Okay, here you in first row there is one rivet, so you have to consider shearing strength for this rivet. Okay, so you have to consider single shear for one rivet. Okay, that is PS. Okay, you have to add PS value, shearing strength. Okay, so 69,360 is the shearing strength value. Okay, this one is shearing strength PS. Now at section 3-3, there are three rivet holes. So you have to consider 3 times the diameter of the rivet. Okay, here PT3 is the tearing strength for third row. Okay, so in third row there are three rivet holes, so you have to consider 3 times the diameter of the rivet. So B minus 3 into D into T into sigma T. Sigma T is the tensile stress induced in the plate material. Plus you have to consider shearing strength. Okay, here this is the shearing strength. Here you have to consider these two rows for determining the shearing strength. In first row, there is one rivet. In second row, there are two rivets. So totally you have to consider shearing strength for these two rows. So totally there are three rivet holes in front of the third row. So PS for three rivets. So here PT3 equal to B minus 3D. 3D means 3 times the diameter of the rivet for 3 rivets. Okay, at section 3, there are 3 rivets. So you have to consider 3 into D. Okay, so 69,360 is the value of PS. You have to multiply with 3 for 3 rivets. Okay, in front of rivets. At section 4, there are 3 rivets again. So you have to consider 3 times the diameter of the rivet. And also you have to add shearing strength for 6 rivets in front of row, in front of section 4. Okay, there are 6 rivets in front of fourth row. Okay, 1 plus 2 plus 3, total 6 rivets in front of the section 4. Okay, we have to consider 6 rivets shearing strength. So 6 into PS, 6 into PS is the shearing strength for 6 rivets. Okay. Now this is the PS value, this is PC value. Okay. After that, you have to select least value of PT1, PT2, PT3, PT4, PS, PC. Okay. Here from these 4 values, the least value is here. This one is a 5 lakhs. This one is a 5 lakhs 94. This one is a 6 lakhs 81. This one is 8 lakhs 81. So from these 4 values, the least value is 5 lakhs 77,000. Okay, PT1 is the least value. Okay, here also above 5 lakhs. So the least value of PT1, PT2, PT3, PT4, PS and PC is PT1. PT1 is the least value. Okay. So the strength of the joint is equal to the least value of PT1, PT2, PT3, PT4, PS, PC. Okay. From the calculations, the least value is PT1. Okay. The strength of the joint equal to 5,77,800 newtons along the section 1. After getting the strength of the joint, you have to determine the strength of unriveted plate. Okay. P dash. This one is P dash equal to B minus T, sorry, B into T into sigma T. B into T into sigma T is the strength of the unriveted joint. Okay. Now we have to determine the efficiency of the joint. Efficiency equal to least strength of the joint. That means least value of PT1, PT2, PT3, PT4, PS, PC divided by strength of unriveted joint. Okay. So the efficiency of the given joint is 91.7%. Okay, this is the answer. After getting the efficiency, you have to determine pitch of rivets and margin and row pitch. Okay, pitch, the distance between two successive rivets is called pitch, and so the pitch value is 95 mm, and the margin value is 45 mm, and the row pitch or back pitch is 75 mm. Okay, this is the sorry, these are the steps for determining the design of the structure joint. Now this is the example, another example problem. Design a lap joint for a mild steel flat tie bar 200 mm into 10 mm thick using 24 mm diameter rivets. Assume allowable stresses in tension compression of the plate material as 112 megapascal and 200 megapascal respectively. Okay. 112 megapascal, 200 megapascal respectively. Shear stress of the rivets as 84 megapascal. Show the disposition of the rivets for maximum joint efficiency and determine the joint efficiency. Take diameter of the rivet hole as 25.5 mm for a 24 mm diameter of the rivet. Okay. So this is the given question. From the given question, first of all, you have to identify the given values. Yeah, the width of the plate is given. that is B equal to 200 mm. Okay, B equal to 200 mm, and the thickness of the plate is 10 mm. That is a small t. Okay, thickness of a plate T equal to 10 mm. Okay, yeah, the tensile stress is 112 megapascal. That is sigma T equal to 112, and compression stress, that means sigma C, crushing stress sigma C equal to 200 megapascal, and the shear stress is tau equal to 84 megapascal. Okay, these are the stresses. Tensile stress equal to 112 megapascal, crushing stress equal to 200 megapascal, shear stress equal to 84 megapascal. Okay, here the diameter of the rivet hole small d equal to 25 mm. You have to use this value for design. Okay, d equal to diameter of the rivet hole, and diameter of the rivet equal to d1. Let d1 is the diameter of the rivet. D is the diameter of the rivet hole. Okay, yeah, these are the given values. Width of the plate 200 mm, thickness of the plate equal to 10 mm, and tensile stress equal 112 megapascal, crushing stress equal 200 megapascal, shear stress equal 84 megapascal. Okay, already we know the diameter of the rivet hole d equal 25.5 mm. Okay, which the rivet diagonal d1 equal 24 mm. In first step, actually we have to design a sort of a diameter of the rivet, but in our question already we know the diameter of the rivet, so no need to calculate the diameter of rivet. Okay, in next step we have to determine the number of rivets required for a joint. Okay, n is the number of rivets required. First of all, you have to determine tearing strength. After that, you have to determine shearing strength and crushing strength. Okay, this is the value of tearing strength for a single rivet, 1,95,440. This is the shearing strength. Here the given problem is a lap joint. Okay, here the given joint is lap joint. For lap joints, you have to consider single shear. Okay, so you have to consider single shear. For double strap butt joints, you have to consider double shear. For double shears, you have to multiply 1.75. Okay, for double shear. But our given problem is lap joint. For lap joints, you have to consider single shear. So this is the formula for single shear, pi by 4 d square into tau. Okay, here the diameter of the rivet hole is given. So 25.5 mm is the diameter of the rivet hole. Tau equal to 84 megapascal. Okay, this is the value for shearing strength for one rivet. This is the value of tearing strength. Okay, now PC is the crushing strength. Crushing strength D into T into sigma C. The value is 51,000. Okay, the formula for a number of rivets required, n equal to tearing strength divided by least value of PSPC. Least value of PSPC. From these two values, the least value is 42,905 newtons. Okay, so PS is the least value. So here from this equation, the number of rivets for joint n equal to 5 rivets. Okay, after getting the number of rivets, you have to arrange in diamond shape. Okay, this is the arrangement of a joint. Arrangement of rivets. In first row, there is only one rivet. In second row, there are 3 rivets. In fourth row, there is only one rivet. Okay, this is the arrangement of the rivets. In third step, you have to determine thickness of the lap joint. Thickness of the lap joint. So T1 is the value of thickness of the lap joint. T1 equal 1.25. For single strap, you have to consider 1.25 T. Okay. So 12.5 mm is the thickness of the lap joint. In next step, we have to determine efficiency of the joint. At section 1.1, there is only one rivet. So you have to consider tearing strength for single rivet. Okay. So the tearing strength, already we know the formula for tearing strength, PT1 equal to B minus D into T into sigma T for single rivet. Okay, so this is the value of tearing strength for single rivet. Now tearing strength for 3 rivets. At section 2.2 there are 3 rivets. Okay, so you have to consider tearing strength for 3 rivets and shearing strength for single rivet. Okay, so PT2 equal to tearing strength for 3 rivets plus shearing strength for a single rivet. Okay, so for 3 rivets you have to consider 3 times the diameter of the rivet, 3D. Okay, for 3 rivets. Okay, so this one is the shearing strength for single rivet, that is PS. At section 3.3 there is only one rivet, so you have to consider tearing strength as PT1. Okay, PT1 equal to PT3, 1,95,440. From these 3 values, the least value is 1,95,000 and 1,81,000. So from these 2 values, the least value is 1,81,000. 1,81,285 is the least value. Okay. So for determine the efficiency of the joint, you have to consider least value of PT1, PT2, PT3, PS, PC. From these 5 values, you have to select least value. The least value is 1,81,285. Okay, that is at section 2.2. This is the value of strength of a unriveted plate. Okay, so the efficiency of the joint equal to strength of the joint. That means least value of a PT1, PT2, PT3, PS, PC divided by strength of a unriveted plate. Finally, the efficiency of the joint is 80.9%. Okay, after getting the efficiency of the joint, you have to determine pitch of the rivet. After getting the efficiency, you have to determine pitch of the rivet, margin, and row pitch. Okay, this is the procedure of a structural joint. In next class, I will explain about eccentric loading problems. Okay, eccentric loaded riveted joints I will explain in next class.